compact indices, the resizing logic, the fast matching, all of that is in here. And so I will post it shortly. And in the end, here's what we get. The output of this is this beautiful little dictionary, which is what I posted to Python Dev back in 2012. Congratulations. Welcome to the third millennium. So let's go back to 2015, when I first came to PyCon in Montreal. And we had a beautiful booth and many nice wax. And by the way, we still have a beautiful booth and nice wax today, and you're welcome to stop by. So many people came over and asked us the same question. Instagram, what the hell are you doing at PyCon? And at first I thought, they don't know what Instagram is. So I started repeating myself and told them that we're a brunch sharing app. And I got interrupted really quickly. No, I know what Instagram is. My friends and family talk about it all the time. My question is, what are you doing at a Python conference? So once they learn we're a complete Python shop, the immediate follow-up question usually is, wow, how do you run Django and Python at that scale, right? Or maybe a more debate-provoking question would be, why haven't you rewritten everything in Node.js yet? And if you will, replace Node.js with Rust or language of your preference. So why did Instagram choose Python in the first place? To answer this question, we have to go back to 2010 and dig the two co-founders, Kevin and Mike. Now, these are two product guys with no real back-end experiences back then. So naturally, when they started, they looked around for the best available framework to help them support the product they wanted to build. And here's what they found out. It turns out the Django and Python framework is one of the most popular frameworks that the co-founders have knowledge of. So after watching a bunch of tutorials and documentations, they set off on their way to 700 million users. Now, what does Instagram love about Python today? First of all, Python is famous for being a developer-friendly language that is really easy to become productive with. In fact, both Lisa and I had only C and C++ background, and we started serious Python development after we joined Instagram a few years ago. Being a popular language also means that it's really easy to tap into the large pool of talented engineers who wants to work in Python. So of the many reasons we heard that people want to join Instagram, one of the frequent ones being, I want to build stuff using Python. Even though we were on a very Asian version of Django for a long time, we were nonetheless able to leverage the maturity of the framework and focus ourselves on business logic and shipping product. So as an example, for over 5 years, we used the Django workflow to manage all of Instagram's user information. That is, we ran out of 32-bit user IDs way before we ran out of the capability provided by the Django framework. And in fact, we've taken Django and Python stack quite far by now. So very early in the days, we've added sharding support to the ORM layer of Django in order to scale out the storage needs for our social graph data. Counterintuitively, we have disabled garbage collection in Python to improve memory utilization in our memory utilization efficiency. And you can follow the details of this on our Instagram engineering blog. We've also expanded Instagram to run across multiple geographically distributed data centers. And we're comfortable to scale Instagram to as many users that are interested in using it as we can find. And this is our very own Carl Meyer talking about scaling Django at the annual Django Under the Hood conference. But it's more than that. In fact, picking Python as a programming language helps to influence and shape the engineering culture here at Instagram. We prefer to use proven technologies. Our co-founder Mike Krieger famously said once that our users do not care what database Instagram runs on. They certainly don't care what language Instagram is developing. The simple and pragmatic nature of Python allows our engineers, our developers, to focus on scoping and solving the real problems for our users and our products, rather than getting stuck on some language details. But you might wonder, Python is still slow, right? Well, if you were here yesterday, you know that Python is not slow for processing hundreds of petabytes of astronomy data. It might be slow if you're doing high-frequency trading or low-level bit operations. But we believe at Instagram, our bigger bottleneck is developer velocity, not so much on pure code velocity. So our conclusion, for which we're certainly biased, is that you can get to a few hundred million users with your product using Python before worrying about the performance of your framework and language. Now, that's not to say we don't care about scaling Python. At some point, we realized that as we continue to scale our team and our product, our server growth is far outpacing our user growth. And things will only get worse as we continue to add more engineers to the team and ship more product to production. So here's our strategy to address Python efficiency. We started by building extensive tools to profile and understand our performance bottleneck. We proactively push
to get here, specific challenges we faced, and finally, where we are today. So Hui was just saying Python is running well for us. Why rock the boat? In last year's PyCon, Guido announced that Python 2 support will end in 2020, and this time it looks like it's going to stick. Fortunately, we were already moving in that direction before that. As Instagram's infrastructure team, our mission is to keep Instagram alive today and tomorrow. So we're always looking for potential scaling bottlenecks that comes our way down the road, 6 months, 1 year, and beyond. So here are some of our motivations. First is step velocity. Take a look at this very typical Python method with an ambiguous argument, max ID. It's an integer, string, tuple. Well, look, our developers have actually been very nice to put a string in there. This doesn't really scale. It's best effort. There's no standard tool to enforce the typing. The comment can also easily get out of sync with the code itself. Worse than no comment. At Instagram, many developers work with multiple programming languages. C++, Java, even PHP in its modern form of Hack supports typing. So that has been one of the most important feature requests from our product engineers, and it was great to see it standardized in Python 3. The second motivation is for scaling our server performance. Let's first take a high-level look at Instagram's building blocks. User requests come into the web server, which accesses various backend services to retrieve information. It might also dispatch some tasks to the async tier to execute, for example, notification, etc. By far the largest tiers that we have is the web and async tier, where we run Python. Now let's zoom in on one server. On each web server, we run n processes on m CPU cores. Each process can only process one request at a time. When the process is waiting for external services to respond with various user information, it cannot execute CPU locally. So we would configure n to be a lot more than m to avoid CPU starvation. But the more processes we have also means less memory budget per process and more frequent process restarts, which in turn will cause more CPU consumption during the process warm-up. The optimal number of n will depend on the CPU architecture, the current user workload, and the ever-changing code base. And it needs continuous tuning to achieve maximum server capacity. What if we can have fewer processes, where n is equal to m, perhaps, but each process can process multiple user requests concurrently, while some requests are waiting for external network responses? We can execute we can serve other requests on the Django. Async I/O is very promising in this respect to help us move forward, and we were very happy to see it natively supported in Python 3, as opposed to the more scattered effort and incompatible solutions that existed in Python 2. Third motivation extends beyond Instagram. Python has a very active development community that continues to push the programming language forward in all aspects. Thanks to all of you for doing great work here. But we'll only continue on Python 3, and we want to be part of it. As Hui was also saying, over the years we have made various patches to the older versions of Django and Python, but that was very hard to upstream. So we want to change that by keeping up with the latest releases of this software so that we can contribute back to the community more easily. So those were great motivations, and we got green light to move forward with the project. Let's just drop everything and work on Python 3. Well, that's not going to happen, right? So we have two mandates that we need to follow. One, there shall be no user impact, no service downtime for the upgrade. Two, there shall be no slowdown of product launches. So our product engineers will continue to ship richer user experience while we move the stack to Python 3 under the hood. How do we make that happen? Well, before we look at several options that we considered, let's take a look at how Instagram ships code to production. Instagram develops code on master with no branches. Our development philosophy is to make small and focused divs, even for large features and refactors. During the development phase, changes are checked into master. Typically within an hour, it is pushed to production. At this point, the feature may not be visible to the user, hiding behind a gated configuration. When the feature is fully developed and tested, it then goes live. Commits like this happens on the master tens of times a day, and deployment continues to happen throughout the day. With that in mind, let's take a look at some options that we consider for migration. First option may be pretty obvious for a lot of companies to take. When you develop a new feature, tap the branch, develop on it, and merge it back. It doesn't really work well for us. As you saw in the previous slides, we have tons of commits on the master every day, and Python 3 really overlaps with the whole code base. So there will be great branch synchronization overhead that is error-prone. Also, if we have run branch, diverged this branch from master for a long time and haven't run it in production, merging back would be a huge risk. If only a handful of developers work on a branch, then we lose the opportunity to educate other engineers who are more than happy to help with the migration. So this option was out. The next observation is that we run the same code on all of our web servers. Any of the servers can serve any requests. What if we convert one endpoint at a time and create a separate pool that runs Python 3 and run those endpoints that have been converted? That might work well for some applications. Like at Facebook, each team owns a different binary and they can migrate at their own pace. It doesn't really work well for us with one binary. Many of our endpoints share common modules that continue to evolve. They are developers work on multiple endpoints, so they'll have context switch between the different Python versions. And there's overhead in managing different pools, and they keep on shrinking and growing. So that option is out as well. I just mentioned common modules. What if we extract those common modules out and make them like a microservice? So instead of local function call, when we need to access these services, we just go out to make a remote procedure call to microservices. Well, that would require massive code restructuring and incur much higher user latency because each request would have to make multiple hops to access these microservices. And the deployment is also much more complex than what we have now. So that option is out as well. Well, since we're so very good at delivering large changes via small steps, we decided that we're going to follow the same practice and just make master compatible so that it can run under both Python 2 and Python 3 virtual environments. So we'll make small changes on master that are version compatible when production is still running Python 2. And when all the code is ready, we switch the virtual app to Python 3 and pray. Actually, we did better than that.